So in this video, I'm going to answer the question, what is the difference between covariance and correlation? So covariance is a measure of the direction of the linear relationship between two variables. A positive covariance indicates that the variables tend to increase together, and a negative covariance indicates that the variables tend to decrease together. The units of covariance are given by the product of the units of the two variables, and hence the magnitude of the calculated covariance is difficult to interpret. In its broader sense, correlation refers to the presence of any statistical relationship between two variables. However, it is usually used to refer to the presence of a linear relationship between two variables. The correlation coefficient is a measure of the strength and direction of the relationship between two variables. Examples include the Pearson correlation coefficient and the Spearman-Rank correlation coefficient. Correlation coefficients are scaled between -1 and 1 and are dimensionless, meaning that they have no units. This makes it easy to compare the correlation coefficients of different pairs of variables. The relationship described by the correlation coefficient is not necessarily linear, but it refers to the Pearson correlation coefficient if not specified. The Pearson correlation coefficient is the correlation coefficient measuring the linear correlation between two variables. It is given by the covariance divided by the standard deviations of each of the variables. Therefore, you may often hear correlation is just normalized covariance. When equal to 1, it indicates a perfect positive linear relationship, and when equal to -1, it indicates a perfect negative linear relationship. When equal to 0, there's no linear relationship, and the variables can be referred to as uncorrelated, despite the possibility of a non-linear relationship between the variables. And so that's all for this video. Thanks for watching.